Hello everyone. In this video we're gonna continue our work problem related to turning effect of force. So the first video we finish like moment of the force. So the second video we will continue our problem related to resultant force and determine the unknown force to ensure rotational equilibrium. Okay, so we started with number 2. Okay, number 2, we're gonna calculate the resultant force of two forces. Okay, so to calculate the resultant force of two forces, you have to take a look the free body diagram for two forces. So they said that two forces, 4 newtons and 12 newtons, and they have the same original point and perpendicular to each other. So we have to figure out our diagram. So we suppose that this point is the point that each force act the same original point. Okay, so the first force, I suppose that is go right. So we may label this one as F1, which is 4 newtons. And then the other one, we suppose that it goes up like 4 newtons, F2. So to get 12 newton, actually 12 newton. So to get resultant force, we may use parallelograms rule or Pythagoras theorem if there are two forces which is perpendicular to each other. So we're going to use Pythagoras theorem or parallelograms rule. So to get resultant force, in this case I'm going to use parallelograms rule and then draw the diagonal line to represent the resultant force. This is F. So we have equation for resultant force if there are two forces which perpendicular to each other. So equation that we're gonna use, which is F equal to square root of F1 square plus F2 square, since F1 equal how many newtons? 4 newtons. F2 equal 12 newtons. So the resultant force is going to be four square plus 12 square. Okay, so 12 square, 12 times 12, which is 144, plus 16, 4 square, 160. You may take 160 out of square root. Okay, 160 out of square root is going to be 12.65 Newton. Okay, so here is the resultant force between two forces. And number 3, a uniform beam of 1 meter is being balanced as shown in figure below. Determine the unknown force F to ensure rotational equilibrium. So we're going to determine the unknown force. Unknown force okay. Unknown force F. So you may use equation that we have like related to turning effect of force. So let's take a look at our free body diagram. So we got two moments in clockwise. Here is 2 Newton. Okay, so moment in clockwise is the moment that rotate forward in forward direction. Moment in anti-clockwise is the moment on the left side of the uniform beam. Okay, so we're gonna label this one as M, this one as M1, this one as M2. So to make it balanced, to ensure rotational equilibrium, unless M moment in anti-clockwise needed to be equal to the sum of moment in clockwise. Okay, M1 plus M2. So moment is the product between force and perpendicular distance, and distance we consider from force F here to pivot, which is the distance from here to here is distance from here to here is 50. So from 10 to 50 you have to take 50 minus 10, which is 40 centimeter. Okay, and distance from here to here is going to be 10 centimeter, because from 50 to 60, make sure that the perpendicular distance we consider from pivot to line action of the force, and this one as well is supposed to be 50 to 90. Take 90 minus 50, which is 40 centimeter. Okay, so we're gonna take force F, moment in anti-clockwise, multiplied by 40 centimeter. You may convert it to meter if you wish, but we're not gonna convert it because on both sides of it we have centimeters. So we can simplify it, equal to the sum of moment in clockwise, which is moment created by 3 newtons over distance 10 centimeters, plus moment of 2 newtons over distance 40 centimeters. Okay, so just like do operation a little bit to get answer. So F multiplied 40 is still 40, so we just like multiply on the right side of it, 30 Newton centimeter plus 80 Newton centimeter. Okay, so equal to 110 Newton centimeter. Okay, so to get F, you may divide by both sides by 40, 110 Newton centimeter over 40 centimeter, and the answer is going to be 11 over 4. Okay, 11 over 4, it would be 2.75. Yeah, 2.75 newtons. So that's how we can determine the force F to ensure rotational equilibrium. Okay, that's it for this video.